So let us have an example of a round robin scheduling with the same example that was given for the FCFS. Assuming that we have P1, P2, P3 in the order of arrival of P1, P2, and then P3, and assuming that they all arrive at time 0. So the burst time for P1 is 24, and for P2 and P3, it's 3, right? So what would be how it would be implemented or executed using the round robin. So assuming that the quantum or the time slice is 4 milliseconds. So since P1 has arrived first, so it gets to execute first. So at this point, the P1 gets preempted since it's only given a time slice or a quantum of 4 seconds. And then the P2 gets to execute. So even if the P2 has been given a quantum of 4 seconds, but it already completed its execution by the third. So it ends at the time period 7. Now, P3 gets to execute, and it's also given 4 seconds, but the burst time is less than 4. So it already finished early by the 10th millisecond. Okay, and now we go back to P1. We go back to P1, and it gets to execute for 4 seconds. And since there are no other processes, then it will just continue to execute until such time that it gets the 24 seconds the burst time, right? So what would be the waiting time for P1? The waiting time for P1 would be 10 minus 4 milliseconds. So how did we arrive to that? So at this point, the P1 gets preempted, correct, at the 4th, and then P2 and P3 have executed. So we have to wait until P2 and P3 complete its execution. So we have to get this time period. So 10 minus 4, that would be the waiting time for P1 because the rest, the P1 is already executing. Right? For P2, the P2 executed or has waited 4 seconds since P1 has to execute for 4 seconds before P2 gets its turn. And the P3 has waited for a total of 7 milliseconds since P1 and P2 have to execute to be executed for at most 4 milliseconds each, right, before P3 got its turn. So to compute for the average waiting time, we simply have to add this all up and divide by the total number of processes, which is 3, and that is equal to 5.66. And what about for the turnaround time? So assuming that the turnaround time for the arrival time pala of all the processes is at time 0. So to compute for the turnaround time, you simply have to subtract or get the difference of the completion time minus the time that they have arrived. So for P1 got completed at the 30th millisecond. And it arrived at time 0. So that's 30 minus 0. So P1's turnaround time is 30 milliseconds. For P2 got completed at 7 millisecond and it arrived at time 0. So 7 minus 0, that is 7 milliseconds. And for P3, it got completed at this time period, 10th millisecond. So minus its arrival time, which is also 0. So 10 minus 0, that is 10. So to get the average turnaround time, we simply have to add this all up and divide by the total number of processes, which is equal to 3. And the average turnaround time would be 15.66. So if we go back to our previous examples in the FCFS, we would see that the average na waiting time for all of these processes, as well as the turnaround time, is much, much better because there is preemption. So this P2 and P3 do not have to wait for the P1 to complete its process before P2 and P3 could execute theirs. All right. So thank you to the preemption. So we have so far improved the performance. Okay. And for the next video, we are going to discuss another example of an RR or a round robin with a different processes and different time quantum as well.